call it gyro maze. So we have a platform, and then we build a maze system on it. So objective is to get the ball from the start to the end point.
Okay.
So we navigate it by tilting this platform along 2 axes of rotation. So this tilting will be in sync with our controller with through Bluetooth. So this is so we face some mechanical challenges, like how do we control the height of this tilt, and then how do we pivot and secure the free moving platform. So we come up with a design. So for our platform, made for a pivot, we should use a point pivot, pyramid shape. Because a point pivot can enable 2 axes of movement. And then we have a very special gear, we call the beaver gear. It's a radius that changes as it turns. So we connect this to a servo motor. Servo motor has a 45 left and right. So with this, right, we can actually control the height by turning the servo motor. So this is all inside here. We have a photo here to show you where is it. So we actually have a pivot here, and then we have the motors on 2 sides. Okay, so this is how we design it. We secure this thing, stabilize it with 4 elastic bands, 2 servo motors at the side. And then we have an extra tension here, such that when the radius reduces on this side, it allows it to tilt towards the motor. And so when the radius increases, you in turn flip it up. So this is how we control this movement, the 2 axis movement. So now, we let you try the game.
Okay, so how you play the game, right? Very simple. There's a button say hold button to start. So you hold this button, then you will say 3, 2, 1. Then you can tilt the game.
Tilt like that.
Yes. So you'll be in sync with your movement.
Let's go. Almost. First time, man.
Almost.
Lousy, I lose.
Can win. But you get the game.
Responsive. Okay, quite responsive.
It's a very simple game, but mostly on mechanical. Yeah.
So inside actually a accelerometer, then over there we transferring from Bluetooth to another Bluetooth. So yeah.
So this one inside accelerometer will read 3 values. Then you convert through some algorithm into 2 values. Bluetooth over and pitch into these 2 beaver gear, and then they will respond by turning according to the angle of your pitch. And then this will control the height. So that's how we do it.
Okay. Then if I hear any sensor to tell me that I win or whatever.
Initially we wanted to put sensors up, but then most of the sensors couldn't really detect. Like for example, if we use an analog distance sensor, right? The values between here and here is around the same, so we can't use.
So can be a limit switch?
We tried limit switch this morning, but then it's too light, so it doesn't press down.
The marble is too light.
Okay, can. Okay, second game, come. Nice.
So this is an adaptation of the claw machine or hook machine. So basically is you have many gifts. Right now we're using pins as representatives of the gifts. And so right now we are using for motion along this direction, we're using 4 DC motors. And on top of that, for X control, we're using 2 steppers on either side. So the steppers are actually working on a pulley system, so they will pull the servo on either side. So to move to the left, this will coil, and to move to the right, that will coil. So that's how you do X control. And for height is the servo motor that will just basically go up and down to pick it up. So basically how you play it is, for the DC motor, we have a touch stylus.
Huh? What is this? What was that?
Okay. So this is kind of a touch sensor. So basically you touch it and the whole thing will move.
Okay.
And so basically for this, what we're using is a potentiometer. So the hook and the left to right control are potentiometers. So the potentiometer passes the reading to the Arduino, and the Arduino will tell the steppers to rotate the pulley. So some of the challenges I faced in this were basically the string tension needs to be exactly accurate. If it's slightly slacking or if it's too tight, then the whole thing will just freeze and refuse to move, and then it will take like a long time to debug it.
So what's your objective? You want to pick up the hook?
Yeah, pick up the hook and place it in the goal. You place it in the goal and then you get the gift.
Oh, can you do it? Can you demo to do it?
Like a normal claw machine is quite hard to do it because it keeps slipping off. But we've tried 3 or 4 times today.
Then if you're successful, how do you know that?
If it's on G, then you know it's successful.
Then is there any sensor to tell you? There's no sensor.
Yeah, first we were trying to add it, but then we had to cut through it, and then it was quite thick at the bottom, and then we couldn't add wires. So then I just skipped that part in the end.
Time
Yeah.
ran out already.
Also, the stepper speed was another issue.
Yeah. Because the torque of the stepper needs to really be quite a lot. So this stepper does not go more than 16 RPM, which is very, very slow. So that's why if you see how slowly this moves, it's very slow.
How many MCU you use here?
One, just one.
Just one.
Just one.
How many MCU you use here? Two. One controller, one here. So 2 games.
Third one.
Third one.
So
Where's the third one?
So this is the third one.
Wow. You all exited the floor space really.
So basically our third game is a mastermind game. So basically just to brief you about the rules. So mastermind game is like it's a 2-player game. First there's a code maker and then there's a code breaker. So the code maker, what he does is he sets a set of 4 different colors. So like right now I'm the code maker. So I set like red and or something like green or anything. Then like this I set some code like anything, and then I place enter. So now I've set the code and it's hidden, and the code breaker sit on the other side.
And he has 8 turns to guess the code.
Yeah, so that's like the maximum number of turns the code breaker gets. And now,
So, for
so he
example,
like places his first guess.
Say that's red,
Yeah,
yellow.
like anything, and then he places, then he presses enter. So
There
now,
are 2 lights there, blue and pink. A blue light tells you that the color is in the correct place, and a pink light tells you that the color exists but it's in the wrong place. So for example, red and red here match, and yellow and yellow match. So it shows you 2 blue lights, but there's no blue or green anywhere. So now if I change this to say yellow, and I press this, will show me 3 blue lights.
because these three are like right now, and then
So
for
now we'll
example-
try showing you, say for example,
Yeah.
if I, what is this, red, right?
Yeah.
Yellow. So now if I press this, the buzzer will ring and there will be 4 blue lights. So that means the code.
So like blue lights are
the
like, and there's like pink light too. So like if for example in
Okay, how many MCU?
just one MCU.
just one MCU. Yeah, that's basically how it works. And we use the fast LED library to control these strips. And it's like along with the blue color, there's a pink color too. So like if there's red here and someone put red there, and the rest are all green, then it would show up a pink light because red is there in the code, but it's not there on the right place. And if it's wrong, then there's no light. So that's
One of the problems we faced was basically the coding for this required quite a few, like you had to take into consideration.
And there was one more thing. If you had noticed that in the code maker, like when the code maker is making the code, the colors can be repeated. So that added to the difficulty because the colors could be repeated. So the code became a bit more difficult because it wasn't like all the colors would be different. It was like repetitive. So we had to debug according to that too. Yeah, and then we set the limit to a maximum
We had to
8
use the
episodes.
previous version of Arduino because the fast LED library didn't work on Arduino.
Those were a few hardships that we came across while making this project. So it's basically more towards coding and less hardware because our other 2 projects focus more on hardware just to prove our
Okay, thanks.
Thank
Good,
you, sir.
thank you.
Thank you so much.